Have you ever felt like there are not enough hours in the day? Well, millions of years ago, days were actually significantly shorter than today. During the era of the dinosaurs, a single day lasted 23 hours. Go back even further, and the Earth spun around in just 6 hours. Our planet is spinning slower and slower with every single passing century. This deceleration is happening right now, even if you cannot feel it. It is a silent change shaping the long-term future of our home. But what is causing this massive planetary slowdown across deep time? The primary culprit is an object we see almost every single night. The moon is actively acting as a giant brake pedal for Earth. This cosmic braking system is driven by the invisible power of gravity. As the moon orbits us, its gravitational pull tugs on our planet. This tugging force creates a massive bulge in Earth's vast oceans. We experience this giant watery bulge as the daily rise of tides. However, the Earth is spinning much faster than the moon can orbit. Because the Earth spins so rapidly, it drags the tidal bulge forward. The watery bulge actually gets pulled slightly ahead of the moon's position. The moon tries desperately to pull that displaced bulge back into alignment. This constant gravitational tug of war creates a massive amount of friction. Ocean water grinds relentlessly against the solid rock of the seabed. This ocean floor friction acts exactly like a pair of giant brakes. It drains the rotational kinetic energy directly out of our spinning planet. As energy is lost, the rotation of the Earth inevitably slows down. Every single day is roughly 2 milliseconds longer than the previous century. That sounds like a completely trivial amount of time to worry about. But over millions of years, these tiny fractions of seconds add up. They completely reshape the rhythm of biological life across global history. Let us dive deeper into the precise mechanics of this orbital physics. This entire cosmic phenomenon is governed by the conservation of angular momentum. Angular momentum is the physical measurement of an object's rotational setup. In a closed system, the total amount of momentum must remain constant. When the Earth loses rotational momentum, that energy cannot simply vanish. It must be transferred directly to another part of the system. That energy is absorbed completely by the moon in its distant orbit. Because the moon gains this extra energy, it speeds up slightly. As the moon accelerates, it climbs higher into the cold void. The moon is actively drifting away from the Earth right now. It moves roughly 3.8 centimeters further away every single year. This distance is equivalent to the speed at which human fingernails grow. Eventually, the moon will be much further away than it is today. When it is further, total solar eclipses will become completely impossible. The moon will appear too small in the sky to block the sun. To understand this better, we must examine a highly critical historical study. In 2018, Dr. Stephen Myers conducted a groundbreaking geological investigation. His research team at the University of Wisconsin-Madison studied ancient rock layers. They analyzed sedimentary structures from a formation over 1 billion years old. By examining these deep layers, they reconstructed the historic Earth-Moon distance. Their calculations proved that days were only 18 hours long back then. The study confirmed that the moon was much closer to our surface. This concrete geological evidence perfectly matches our modern mathematical models of physics. It proves our planet's deceleration is a constant, measurable historical fact. However, this slow journey has not always been a smooth ride. There is a fascinating evolutionary counter-argument regarding this specific timeline. Geological data reveals a massive anomaly during the Proterozoic era. For nearly 1 billion years, the Earth's rotation stopped slowing down entirely. The length of a day stuck stubbornly at exactly 21 hours. Scientists refer to this bizarre static phase as the boring billion. During this era, a second powerful force countered the moon's grip. That opposing force was the intense thermal tide of our atmosphere. The sun warms Earth's atmosphere, creating a distinct global atmospheric bulge. The sun's gravity pulls on this warm air, accelerating the Earth's spin. For 1 billion years, the solar acceleration perfectly balanced lunar deceleration. This planetary tug of war achieved a state of temporary resonant equilibrium. Without this atmospheric push, our days would be much longer today. Eventually, shifting global temperatures broke this delicate planetary lock forever. The moon regained control, and Earth resumed its slow, steady deceleration. What does this ongoing slowdown mean for the future of humanity? In the short term, our technology must constantly adjust for this change. Atomic clocks keep track of time with absolute, unmatched precision. But our rotating planet lags slightly behind these perfect atomic machines. To fix this discrepancy, scientists introduced the concept of leap seconds. A leap second is occasionally added to keep our clocks synced. The last time a leap second occurred was in December 2016. These tiny adjustments ensure our global navigation systems remain entirely accurate. Without leap seconds, GPS tracking would become completely useless over time. Digital financial networks would experience massive, chaotic timing errors worldwide. Looking ahead millions of years, the changes become truly massive. Thousands of generations from now, the human calendar will look different. A standard year will contain significantly fewer individual days than today. This is because the Earth takes longer to complete one rotation. The actual time to orbit the Sun remains completely unchanged, though. Eventually, the Earth will slow down so much it locks entirely. This theoretical final state is known as absolute tidal locking. One side of Earth will permanently face the distant, retreating moon. The other side of Earth will face away into dark space. A single day will last for roughly 47 of our current days. The moon will hang completely motionless in the dark night sky. It will never rise or set from that fixed cosmic position. Fortunately, this extreme scenario will take billions of years to occur. Our sun will likely run out of fuel before that happens. But the steady slowing of our world remains a profound truth. It connects our daily lives to the vast mechanics of space. Every passing day is a tiny monument to this cosmic dance. Time is literally expanding beneath our feet with every single breath. The universe is slowly reshaping the rhythm of our spinning home.